All right, so example 4 gives us an area question. We have definite integral from 0 to 1 of arc sine with respect to x. And you can see the graph here. We're definitely finding the area underneath the curve. So we have, yet again, kind of like the natural log function, we have arc sine of x, and it doesn't look like there's a product in here. Well, we don't have an antiderivative rule for arc sine, not one that we've written down, but we're going to treat this in the same kind of way that we treated the natural log one. If I write down Lipit, we have the arc sine of x is the inverse trig, which is the I. It's pretty close to the left-hand side. And then just like we did before, we'll have an understood 1 in here for our second function, which should be the power function right there, okay, which is further to the right. So we're going to do it basically the same way that we did the natural log function. So here, let me rewrite the problem down. And we're going to let u equal arc sine of x, take its derivative, and that should be dx over square root of 1 minus x squared. Whew, all right, if you say so. All right, and then our dv is going to be equal to just the dx, take its antiderivative, and v is equal to x. All right, how does that help us? It looks like it's just as complicated as the integral that we started with, right? However, if we multiply these two along the diagonal, the v du, this x is going to go on top. And then this one turns out to be a regular u substitution because the derivative of 1 minus x squared is going to be a negative 2x, which we can make that happen with this x that's on the top of it, right? Okay, so that's the technique here. So I'm just going to write it down again. Here, 1 arc sine x dx is equal to uv, I'll bring the x right up front, x arc sine x. And remember that this part also gets the 0 and the 1 whenever we do our fundamental theorem of calculus, minus definite integral from 0 to 1 of x, or I should say u dv, which is going to be x dx over the square root of 1 minus x squared. Okay, so this definite integral here, we're going to evaluate with traditional u substitution. And I know that, of course, because we have a composite function here, and the derivative of this composite function is going to be just a regular function of x. It's going to be x to the first power. So I'm going to do this one probably in a different color. This u, different from the original u, don't let it confuse you. So u is going to be equal to 1 minus x squared. Du is equal to negative 2x dx. All right, so we have to fix this. Remember in the original integration by parts thingy, no, the original u substitution, we often have to fix this. Now, I already have a negative sign. Really, it's right here. So what I could do is just bring this in here, right? All right, and then the only thing I really have to fix is the 2, and I'll fix that with the 1/2. Now, as far as this 1/2 goes, it is only on the second part. It's not on this first part here. Okay, so I need to rewrite this, and I would actually have to rewrite this 0 and this 1 here, but I'm not going to worry about that. I'm just going to ignore them and then just fix it at the very, very end, because then it becomes even more complicated because the original thing gets 0 and 1, but this one in terms of some sort of views will not. It would get different numbers here. So I'm going to ignore them and then just come back to them after I do my back substitution in terms of x's. So let's bring down x arc sine x plus 1/2 antiderivative of negative 2x dx. All of that is our du. Okay, and then the square root of 1 minus x squared is going to be, it's going to be u to the 1/2 power. Right, and then I'll rewrite that as u to the negative 1/2 power. And now we're ready to take the antiderivative of this guy here. All right, so antiderivative of u to the 1/2. Why did you get erased? I don't even know. All right, add 1 to the exponent. It's going to be u to the positive 1/2 times 2, which conveniently means that those things are going to cancel each other out. But what I definitely need to do is go back and resubstitute 1 minus x squared in here before I go ahead and use the fundamental theorem of calculus. So the 1/2 and the 2 are gone, and all I have is u to the 1/2. That's the square root of our u function, which is 1 minus x squared. Okay, and now we can evaluate that from 0 to 1, the original bounds of our integration here. Well, you know what I like to do, right? I like to check to make sure that my antiderivative is correct, and I'm going to do that by taking its derivative. So let's say that our function is x arc sine x plus the square root of 1 minus x squared, or if you prefer, all of that to the 1/2 power. Okay, so y prime is equal to, using the product rule here, derivative of the first one is 1 times the second one, arc sine x, plus the first one times the derivative of the second one. So the first one is x, the derivative of the second one is 1 over the square root of 1 minus x squared. Okay, plus, and now taking the derivative of this one here, I've got, let's say, a leapfrog, so 1/2 1 minus x squared to the negative 1/2 power. Now multiply it times the derivative of the interior here with the chain rule, and you get a negative 2x. And of course, half and the 2 cancel out, but the negative doesn't. Can you see where this is going? Hopefully you do. Let's bring some stuff down. Arc sine x, x over the square root of 1 minus x squared. And then this whole sign is going to be negative here because that negative sign there. That x is going to go on top of this as a square root in the bottom. And then those two terms cancel each other out. Matter and antimatter, and then we have our original sine x, arc sine x. So we did it correctly. Hooray! All right, so now it's time to just plug in our 1 and our 0. We do, in fact, still have to plug in a 0 because it's going to affect this. It's going to affect that one as well. Okay, so plugging in our 1. Remember, it gets plugged into the first part of this as well, not just the little square root part. So I have 1 times the arc sine of 1. That's supposed to be 1, yes. Okay, plus the square root of 1 minus 1 squared. That'll be nice. Minus, now plugging in 0 everywhere, 0 times the arc sine of 0. And then plus the square root of 1 minus a 0 squared. Yes, yes. Okay, so this first part here, arc sine of 1. So think of a unit circle, perhaps, and really we're saying, hey, the sine of some sort of angle is equal to 1. So where is sine equal to 1? That's right up here, right, at pi over 2. So we got pi over 2 for the first part. This square root is gone because that's 1 minus 1 is a 0. That's gone. It gets canceled. That's really nice. All right. And then 0 times I don't even care. That part's gone as well. It gets canceled. And then here we have the square root of just 1. And we have to subtract it, distribute your negative sign through this to get minus 1. So here we have the area underneath the curve, which is what we were looking for all along. Pi over 2 minus 1 for this area, which seems obvious to me.